Onward to activity 6.3, building expressions. So in this activity, we're going to examine some different situations, and then we're going to try and come up with an expression to represent the situation if we don't know one of the numbers in the situation. And then we are going to use that expression to write an equation and solve the equation. Sometimes, some of you can solve a lot of these in your head, so you may not see the value in actually writing an equation when you can just solve it mentally. But the thing is, as we continue, as we progress through this unit, we're going to be representing situations that are not so easy to solve mentally. So you need to have the practice of actually writing an equation. Okay? I know right now it might seem tedious, but it will be helpful for you later on if you do this practice. Okay, so let's start. Number 1, Claire is 5 years older than her cousin. Okay, so Claire's age is going to be her cousin's age plus 5. How old would Claire be if her cousin is 10 years old? So Claire's 5 years older. She's going to be 10 plus 5, or 15. If her cousin's 2 years old, and Claire is 5 years older than her cousin, it's going to be 2 plus 5, or 7. So if we don't know how old her cousin is, if we look at these other examples, we just know Claire is going to be her cousin's age plus 5. So here we can't come up with an actual number. Excuse me. We have to leave it as an expression that contains a variable. And you're just going to have to learn to be okay with that sometimes. Now, we're told Claire is 12 years old. How old is Claire's cousin? So we know we can represent Claire's age by the expression x plus 5. And if Claire's age is 12, then we can say x plus 5 must equal 12. And to use this, then we can figure out what her cousin's age is. We would subtract 5 from both sides of this equation, and we would get that her cousin's age is 7. Okay, let's move on to the next one. Diego. Diego has 3 times as many comic books as Han. So however many comic books Han has, Diego has 3 times that amount. How many comic books does Diego have if Han has 6 comic books? Well, he said he has 3 times as many as Han, so 3 times 6 is going to be 18. What if Han has n comic books? So n just means we don't know how many comic books Han has. We're going to use a variable to represent that. But we know Diego has 3 times as many, so Diego is going to have 3 times n, or 3n. Okay. Now we're told Diego has, part D, Diego has 27 comic books. How many comic books does Han have? So the number of comic books Han has is going to be n, and Diego has 3 times as many as Han, and we know that number is 27. So to figure out what n is, to solve this equation, we have 3n. We want to know what 1n is. We divide both sides by 3. 3 divided by 3 is 1, so I have 1n, and on the right side of the equation, 27 divided by 3 is 9. So here, Han would have 9. All right, let's move down to number 3. 2/5 of the vegetables in Priya's garden are tomatoes. So, I know however many vegetables there are in Priya's garden, 2/5 of that number are going to be tomatoes. Here they're using X to represent the number of vegetables. How many tomatoes are there if Priya's garden has 20 vegetables? So 2/5 of 20 is going to be the number of tomatoes. So 2/5 of 20, and in math, of translates into multiplication. So I have 2/5 times 20. I'm going to put that over 1. And when I multiply straight across, I get 40 over 5. And 40 divided by 5 is 8. So if there's 20 vegetables, 8 of them are tomatoes. So what if there are X vegetables? As we said, we're going to represent the number of vegetables with X. And we said if 2/5 of the number of vegetables are tomatoes, we can just multiply the number of vegetables by 2/5. So this is no different when I don't know exactly what the number of vegetables are. It's still going to be 2/5 of that number, or 2/5 times X. And again, so here I can't come up with an actual number. I have to leave it as an expression that contains a variable. Now, B. Priya's garden has 6 tomatoes. How many total vegetables are there? Well, I know if X is the number of vegetables, 2/5 of that is the number of tomatoes. And here I'm being told that number is 6. So I can write an equation, 2/5 times the number of vegetables is equal to 6. And I want to know what the number of vegetables are. So to get 1x, I'm going to divide this side by 2/5 because any number divided by itself equals 1. But then to keep my equation true and balanced, I need to do the same thing to the other side. So 2/5 times 2/5 is 1. So that just leaves me with 1x. But over here, I've got to do 6 over 2/5, or 6 divided by 2/5. So I'm going to write that as 6 over 1 divided by 2 over 5. And then I can keep change flip. So it becomes 6 over 1 times 5 over 2. This gives me 30 over 2 when I multiply straight across. And 30 divided by 2 is 15. So this means that 1x is equal to 15 vegetables. All right, last problem. A school paid $31.25 for each calculator. So the total amount they're going to pay for calculators, the total amount is going to be the number of calculators times $31.25. So if the school bought X, an unknown number of calculators, how much did they pay? Well, it's going to be $31.25 times the number of calculators. So 31.25 times X, right? And this is why we stop using the X as a symbol for multiplication, because you can see what sort of confusion that would lead to in this expression if I wrote 31.25x. All right. The school spent $500 on calculators. How many did the school buy? So that means 31.25 times the number of calculators has to equal 500. So there's the equation I have to solve. I want to get x all by itself because I want to know what 1x equals. So I'm always just going to divide by, we call this number the coefficient. The number that is multiplying a variable is called the coefficient. I'm going to divide by 31.25. So on the right, that's really easy. I mean, on the left, it's easy because 31.25 divided by 31.25 is 1. So I'm left with 1x. On the left, it's a little trickier. I still have to do the same thing to both sides of the equation, but this is leaving me with kind of tedious division problem I have to solve. So I would do 500 divided by 31.25, but I'm going to get rid of the decimal points by moving my decimal point over 2 places. So I'm going to add 2 zeros on there, and if I move my decimal point over 2 places there, it's 3,125. It's really the same division problem. It's just I don't have to keep track of that decimal. All right. So 3,125. This obviously isn't something that's within the realm of my math facts. But what I can do is think about estimating. 3,125, I could round that to 3,000. And let's see, if I go all the way to here, that's 5,000. So I could think, how many times will 3,000 go into 5,000? It will go once. And I could be off on this, but this gives me a good place to start. 1 times 5 is 5. I got to make sure I keep everything lined up here because I didn't use that last 0. So I don't want to put the 5 all the way over. 1 times 2 is 2. 1 times 1 is 1. And 1 times 3 is 3. Okay, I got to do some subtracting. I can't do 0 minus 5. I've got to go all the way over here to borrow. So that becomes a 9, that becomes a 9, and that becomes a 10. 10 minus 5 is 5, 9 minus 2 is 7, 9 minus 1 is 8, and 4 minus 3 is 1. 3,125 won't go into 1,875. It's larger, so now I'm going to bring down this to 0. And again, this isn't in my realm of math facts. I'm going to do some estimating. So again, I'm going to think if I round this to 3,000, and I round this to 18,000 or even 19,000, how many times will 3,000 go into 19,000? Well, 3 will go into 19 6 times, so I'm going to try 6. 6 times 5 is 30, carry the 3. 6 times 2 is 12, plus 3 is 15, so 5, carry the 1. 6 times 1 is 6, plus 1 is 7. This is looking pretty good. And then 6 times 3 is 18. So that was a good guess. So in this case, x equals 16. So they can buy 16 calculators. All right.